This is the session on origin science, how it differs and why that matters. My name's Erika Mildred, and of the many hats that you wear and the many hats that I wear, you understand how many hats we all wear, but I am kind of under the umbrella hat of my responsibilities as a faculty member of Wittenberg Academy. I teach in their natural philosophy department, and when we get into the topic of defining science, and Dr. Veith has already kind of mentioned that a couple times in his plenary, you'll understand why Wittenberg Academy does not call it our science department. They call it Department of Natural Philosophy. So we'll go ahead and get started here. And a good question to always ask is, where do we start? So to quote Julie Andrews, let's start at the very beginning. A very good place to start. Can everybody read it okay? I know it's a little light with how the lights are, but if I turn it off, then you really are in the dark, which actually may be okay because it's a space kind of background. But okay, if you can't see, let me know and I can turn off more lights. But we know as Lutherans that in the beginning, God created the heavens and the earth. And this is what we teach our children. We teach them in our Lutheran schools and in our Lutheran homeschools, in Sunday school and at church services, in chapel and at home. And then they grow up. And I don't even mean become an adult. I mean they grow and they grow and they grow throughout childhood. And they are exposed to things as they grow up in our country. There are 60 national parks in the United States alone. There are over 3,000 national parks worldwide. There are over 35,000 museums in the United States alone. And in all of these places, our children are exposed to a message, and it's pretty consistent. It is a message of millions and billions of years. It is a message of a theory that has never been proven. And if you corner the academia in it, they will say, of course, it's a theory. No one can prove it. But that's not how they teach it, and that's not how they expose our children to it. And even if your school or homeschool uses AIG, Apologia, ICR, or Memoria Press, children are exposed to naturalism as an explanation for origin through cartoons and movies, through news reports, through literature, in those museums and national parks that I already mentioned, and just in daily life and interaction. Unfortunately, especially in our country, it is just assumed and it is everywhere. And then they hear in their formal education, the age of the universe is a scientific fact. Radiometric dating proves the Earth is 4.55 plus or minus 0.05 billion years old. The universe is 13.799 plus or minus 0.021 billion years old. Notice the precision of those numbers presented. What's interesting is if you look back a decade, if you can find documents from a decade ago, because they won't tell you that it's changed, but if you can find documents that were put out a decade ago, those numbers are not there. Those are different numbers. And if you look back a decade before that, they are different numbers again. So these numbers keep changing, and yet look at the precision. What does that precision imply to our children when they look at it? That looks like that is a fact. Faith and belief, they are told, are not scientific and have no place in the scientific community. Ideas about a divine being creating the universe, they are told, are theological speculation. Naturalistic evolution, they are told, is science. So they're told that there's this very big chasm between science, which is of reason, of logic, and of fact, and faith, which is of mysticism and belief and superstition. It is very much a either or, not a both and. And if you're in this camp, there's no way you can be scientific. So let's go back to the beginning again. Let's talk, before we talk about origin science, let's talk about the origin of the word science. The first thing we must teach our students is that the word science is often used equivocally from those who support evolutionary naturalism. What is the origin of the word science? Well, Dr. Veith has been talking about it when he gets into his quadrivium. It's from the Latin verb scire, which means to know. Thus, science in its broad definitional use and the use of the word science for over 2,000 years before it started adopting this more modern understanding of the word really was used to be how we come to know something. They were the know subjects or the knowledge subjects, what we would today call the philosophy subjects. Which is why, getting back to my introduction, Wittenberg Academy calls my department that I work under natural philosophy. How we know what we know about nature and the world around us. Used today, the branch of study known as science is interested in a systematic approach to understand and to know about our physical world and universe in which we live. And we, as Christian scientists, would not disagree with that. We do want to know and understand about our physical world and the universe in which we live. Typically, though, and we don't call it this, you don't hear it called this, but typically this is what is called observational science or operational science. It's where things like chemistry and biology fall. It is where, when you are working with things like electricity or a formula on anything really, where math and science interact together, and you calculate things that are measurable, where you use beakers and test tubes and microscopes. This is really observational science or operational science. Notice, especially in the word observational science, it's because we are right there observing what is going on, and then we are drawing conclusions about what we can know from what we have observed. In the realm of science, we make these knowledge discoveries. I call it that instead of scientific, right? But that's what it is, knowledge discoveries, through observation, hypothesis, testing, and drawing conclusions based on results. Loosely, this is what we all know as the scientific method. The branch of origin science, which has also fallen under the name historical science, which I think is very interesting, is to study and determine what we can know about the origin of our physical world and universe. Here is the first very important difference compared to other branches housed in the camp of science, and something that we have to help our children recognize from very young. Unlike the height of a tree, the chemical composition of a molecule, the speed of a bullet, or the distance between two objects, no one living today observed and recorded measurements in the beginning. Regardless of when you say in the beginning was, no one was there to record that, and we have no observations in our record today. Now, I'm adding in this, at this point, just a little bit of humor. What it might have been like had Adam and Eve perhaps started experimenting with science and learning observationally about things after the fall. So we'll put a little after Eden in here for us. So here's science class for Adam and Eve. Adjusting from paradise to life in a cursed world, Adam and Eve would often update each other with new discoveries. Don't pent the skunks, leave the beehives alone, and so forth. But even if they had these observations and hypotheses and conclusions that they were drawing after the fall, nonetheless, that these things were not recorded. And more specifically, the time in which these things happened were not recorded. So because none of us today were there in the beginning, all scientists must make some assumptions in the arena of origin science. For example, they have to assume the original amount. We know how much of a substance is here today. We have to assume how much was there in the beginning. The starting point or position of anything in the universe. We can measure how far it is from the Earth today, but where did it start? Was any parent or daughter amount added? And that has to do with as things decay over time. Was any parent or daughter amount removed? What was the rate of that decay or the increase if it was growing over time? And was that rate of decay or increase variable, meaning it changed from time to time period, or was it constant throughout time? Now, these are assumptions that all scientists have to make, whether they are naturalistic evolutionary scientists or whether they are creation scientists or sometimes called young earth scientists. All of them make this, and this is what we have to help our students know. They need to know that these are the assumptions that are being made before any calculations are occurring. After these assumptions are made, calculations can indeed be done using observations and measurements today and then applying them to the past. But notice that because we have to make these assumptions, the calculations that we get as answers do not create scientific fact on our side or on their side. They are speculations based upon assumptions. Now, creationists and evolutionists differ in their interpretations because of these different assumptions made. We actually use all of the same stuff, if you will, the same rocks, the same distances that we currently see, the same decay rates in radioactive isotopes, and so forth. Okay, so we're going to go ahead and do an exercise now. I would like you to look at the drawing below. This drawing represents a fact. We could even call it an artifact. We're going to let this drawing be our fact that we all have before us. So the question I pose to you is, what is missing? What was there originally? So I'm going to give you a minute to kind of think about that. Think about those questions and think about our fact. And I want you to, in your mind, picture what your answer is. Okay, or if you want to draw it on your paper, you can. Does everybody have in your mind what the answer is? Here are some possibilities some of you may have thought of. I will admit this is what my mind did when I first did this exercise. Perhaps some of you were folks too. Perhaps some of you are really hungry for lunch, and so C was something you came up with, or maybe you drew teeth on it because you're really, really hungry. Or perhaps it was F, some mystery option you haven't even seen yet. But which interpretation of the fact is correct? All of them, none of them, most of them, okay? The actual answer is nothing is missing. I drew the fact just as you saw it. This simple exercise teaches us a very important lesson about evidence and interpretation. Notice that I started you with a question. What is missing? And by doing this, I gave you a particular presupposition or assumption. I saw your face. I think that that's what you were thinking. That's good to use when looking at this fact. This would be a great exercise to do with your students. Because really, if you interpreted the object like I did originally as a circle, you accepted the assumption I placed before you as true, that something was indeed missing. In origin science, we need to teach our students to question the question. In other words, we need to ask, how do we know? Notice that science word, know. How do we know that something is missing? So how do they know? Think back to how old the universe is according to naturalism. 13.799 plus or minus 0.021 billion years. Of course, we as Christians know that in the beginning, God created the heavens and the earth, that he created them in 6 days and that he rested on the seventh. And that if you use the genealogies provided in the Bible, you can actually get a range, because there are theological scholars who debate whether it was a father or a grandfather, whether there were certain few gaps in the genealogical record and so forth. But you still get a range, somewhere between 6,000 if there are no gaps whatsoever, to between 10 and 12,000. So it's still a very small range. So we know all of this. But how do they know? How did they get that number? Even though that number was different a decade ago, where did this number come from? Well, D equals RT is a very simplified explanation, but we will go through it in more detail in a minute. This is a simple physics formula that basically says that distance, rate or speed, and time are related to each other in this fashion. That the distance between two objects always can equal the speed multiplied by the time. And we know that the speed of light is constant. C equals 3.00 times 10 to the 8th meters per second. We have never seen it change. I suppose we should probably have to say no in quotations, because ultimately we still don't know what happened at the beginning. But even creation scientists accept this. This is universally accepted among scientists and among teachers and professors and so forth today. So this is the R of the equation. This is the rate, the speed of light. So to calculate how old the universe is, how old would be a time in the equation, we must know what? If we know this and we want to calculate this, we must know distance. So then we should ask the distance to what? What did naturalistic evolutionary scientists measure between in order to use this and the speed of light in order to give us this number? Well, according to Wikipedia, astronomers estimate the age of the universe in 2 ways, but it all goes back to that formula. They look for the oldest stars, that really should be in quotation marks, and by measuring the rate of expansion of the universe, they extrapolate it back to where they believe the Big Bang occurred, a spot in the universe, which then has a distance away from Earth. So notice that on the surface, and don't panic as we go through this, notice on the surface, this seems to be a scientific calculation of D equals RT. Since we can measure the distance between the Earth and the oldest stars, and we can also measure the rate of expansion of the universe, which we can. We can do those two things, although, again, oldest should be in quotation marks. So clearly it is scientifically proven that the universe is almost 14 billion years old, right? And this is where most students stop. They just accept this. This is an example of where we need to help our students look more closely. Astronomers, here's the quote from the previous slide, estimate the age of the universe in 2 ways, by looking for the oldest stars and by measuring the rate of expansion of the universe and extrapolating back to the Big Bang. What assumptions are being made about these so-called oldest stars? Well, first of all, there is a naturalistic assumption of star ages and star personification. What do you know about stars? Have we ever seen a star they even talk about stars being born. Well, let's start with this. Are stars alive? No, they are not alive. They are balls of gas, okay? So they are not alive, right? They're not living, right? And I will get to this candle example in a minute, but they're not living, right? They are not alive. So, but we talk about them being born. That's what I mean by star personification. Now, I don't like using that term, but have we ever seen, let's just say, have we ever seen a star come into existence? The answer is no. No scientist has. They keep looking for it. They have seen stars in all of how they label a born star or a baby star has to do with how much fuel it has. And the way they can tell, because obviously you can't just go up to the star and measure how much fuel it has, the way they tell is by color. and by heat. Okay. And so these stars over here that have lots of fuel are the baby or the newly formed stars. Okay. And we have clusters of these that they've found that have lots of newly formed stars. However, the formation process of a star still takes such a long time that we never have seen it in action. What we do see all across the expanse of our universe are stars that are in all of these stages. Now, they say stages of life, again, personifying stars. Now, what do we know as Christians about all of these different stars and all of their stages? Well, when God created them, he created them this way. And it struck me as I was looking in chapel today at most Lutheran churches now have not actually lit candles, right? We have the ones where we pour the little oil or whatever. And that's one of the things the altar guild does is make sure they're up, because if the oil goes all the way to the bottom, the poor little acolyte keeps trying to light it and it just doesn't light, right? So we try to keep it up here, don't we? Now, imagine if I told you, if we went to all these different churches, and we're going to have to kind of make this analogy a little absurd to fit it to stars, but we're going to go ahead and do this. Imagine if you took candles from all these different churches. Okay. And imagine if they stayed eternally lit. All right. Imagine if they're just all lit all the time. And we line them up in terms of oil. And then we say to you, or we say to everybody else, well, look, this candle is a baby candle, right? And then this candle over here, way at the end, this is a very old candle. It has been burning a long, 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 long time. This candle has not been burning that long. What would be the problem with saying that? We don't know how much fuel was in there to start with. We don't know if this candle in this church had an altar guild staff that after every single worship service went back and poured more oil in it. Even though the candle, again, I know it's absurd, but it's saying always lit, right? If we had some way to, fill it from the bottom or something. Right? Likewise, we don't know if this one, they just choose to only fill it up to here. And then when it comes down to here, they fill it up. We don't know the rate at which they were refilling it. We don't know how much parent or daughter information was added and so forth. So even though they're all lit all the time, this is not a good way to explain the age of the candle. In other words, how long it's been burning. But this is exactly what we do with stars. And then we assign it cutesy words like baby stars and old stars and so forth. And, our star is in the middle, but it's a star that has been, I think it's has been burning for 13 million years and has 13 million years left. That's really not true. It's just halfway filled. Well, when God created it, in order to provide light and heat at the exact right temperatures and so forth for the plants to grow and for us to live, he had to fill it at the halfway point. If he filled it all the way up, it wouldn't work. If he filled it here, it wouldn't work. Okay, so when Abraham saw stars in the heaven, right, he saw all of really what he's seeing is the light, the star's light. And that light was already there, even though, yes, we can measure the distance. And the distances are millions of light years away. But that is only the case if the light started at that point and then traveled those millions of years to Earth. But when God put the stars in the heaven, he didn't just put the stars there. He put the light there for Adam and Eve and for Abraham and for all of us to see. So what is the assumption that's being made about the rate of expansion of the universe? Going back to the next part, by number 2, by measuring the rate of the expansion of the universe. The universe is expanding. But what are we assuming? It all started in one spot. It's doing it at the same rate over time. So we just kind of do the reverse process and we'll get to that spot. Okay, all of these things are assumptions. What is being assumed about the Big Bang? Yeah, that it's true, that it actually happened, that there is a spot that we can measure it. How do they know that it started here and not here, right? So notice when you count up the number of assumptions and then you ask the question, would different assumptions result in different calculations using the same D equals RT formula? Absolutely. It would absolutely result in different calculations. I'm right, you're wrong. There are many examples to which we could point in the young Earth, old Earth debate, and to the time we have, we'll revisit these in order, that stem directly from these assumptions. Radioactive dating contradictions, carbon-14, we'll do these two together because carbon-14 is a type of radioactive dating method. Low-level seafloor sediment levels, bent rock layers without fracture, soft tissue found in dinosaur fossils, rapidly decaying magnetic field, helium in radioactive rocks and also in the atmosphere, very little salt in the sea, and the distance between the Earth and the Moon. And these are just some of the many. The body of evidence of all of these different things is the same. We all have the same sea and the same amount of salt in it. We all have these same bent rock layers to interpret. But the assumptions made dictate the interpretation. And that's what we have to teach our kids. And it can't just be one time and done, over and over, because they are going to, at some point, they are going to be confronted with the alternative. And this is not to say that the Bible is true and that we believe what the Bible teaches. But when you're talking to an evolutionist, that book does not matter to many of them. So we need to teach our students to ask questions and to confront the scientific assumptions. Okay, so identifying assumptions. The key to teaching students about origin of science is to equip them with how to identify the assumptions used. As stated before, all scientists make them. Encourage students to find the assumptions and then to ask questions about these assumptions. Let me go back to this one for just a second. When you start showing your students research from creation scientists, you will see they lay out the assumption. If we assume this percent, if we assume a decay rate of this, they put it right into their research. So if they read enough of that and then they read something that's secular, they will see that those assumptions aren't even laid out. AIG, which is Answers in Genesis, ICR, Institute for Creation Research, CRS, Creation Research Society, and CMI, Creation Ministries International, are all great organizations to find resources on origin science topics. The top two that I named, AIG and ICR, are my biggest go-tos. I think they're the largest right now. They're the ones that are getting funded through donations and outside sources. And so they're able to hire on more scientists who are able to put forth more research and so on. Okay, what may we conclude from this? Our faithful belief in Scripture as the truth does shape our assumptions as Christians about the age of the earth and the universe, as it should. Likewise, an evolutionary naturalist belief that there is no divine creator shapes his assumptions about the age of the earth and the universe. Both assumptions are based on belief. Both assumptions lead to additional assumptions that I listed before that must be made when calculating age in origin science. And these differing assumptions will lead to great differences in calculations of the age of the earth and the universe. I teach older students, 7th through 12th graders, and so that's one of their biggest questions to me. It's not that they question the creation scientists. It's that they don't understand how there could be such a vast difference. How could there be so many things that say millions and billions? And then you have these scientists on the other hand that are saying, no, this is the reason. So this will at least, it gives them a logical reason, even if they're still not happy that it is the way it is. We must equip students to identify those assumptions in order to stand firm in their faith while participating in the scientific community and living in our world today. Our students are not anti-science by pointing out these assumptions. And the nice thing is they're actually talking in the realm of science, which is allowed as they do so. Okay, so as I promised, we have about 15 minutes left, and we'll get through as many of these as we can. And again, all of these can be found, especially on AIG and ICR. So if you're interested in any of these topics, rather than trying to write all of this down, just write down the topic and then look up later that topic in one of those two sources. You'll find plenty of information. So radiometric dating. Radiometric dating of a group of meteorites is where they get the secularly accepted age of the Earth of 4.54 billion years. That's another thing I think you should teach your students. Don't just say, well, we know this is wrong. It's good for them to know how'd they get that number? Where did it come from? Oh, okay, they used the radiometric dating of meteorites. Okay, but don't stop there. The results from other radiometric dating methods, such as C14, completely contradict the radiometric meteor dating. So C14 is carbon, and C14's half-life is currently, the rate is 5,730 years. Okay, C14 is only found in living things, and it begins to decay into nitrogen once the living creature dies. So we do have a nice, in today's world, starting point of when C14's half-life begins in a creature, okay? As long as we can measure when it died, we can start measuring how long it's been dead, and then we can measure the half-life of C14. Now, interestingly, I mean, that may seem like a long time, right? But that's actually considered very short in terms of half-lives. This means, though, if you take the half-life, and then you take the half-life again, so every 5,730 years, and you're assuming a constant rate, in about 100,000 years, essentially all of the C14 should have decayed into nitrogen. There just should be, I mean, such a small infinitesimal amount that it really isn't even measurable, okay? However, fossils, diamonds, and coal have all found to have not just infinitesimal amount, but traces of C14 in them. So clearly they can't be millions of years old. Similar problems are seen with potassium-argon dating. We use that for volcanic rocks from known eruption dates. And I don't know who I was talking to or which presentation it was in, but someone mentioned Mount St. Helens, right? It erupted in AD 1986. We know this. Many of us were living when that one happened, all right? But if you go and you use KAR dating methods, those rocks that we know just were formed in 1986 are dated up to 2.8 million years old. So clearly the radiometric dating is not accurate. So we can't use it then to date accurately anything else. And I really like this one, the one in Hawaii. Oh yeah, it's between 1.7 and 15.3 million years. Nice small range, right? A second problematic assumption, there is very little sediment on the seafloor. So every year, about 20 billion tons of dirt and rock from continents are eroded and deposited on the seafloor. After 3 billion years, if this decay rate continued in a regular fashion, and 3 billion, why 3 billion? Because that's how long secular scientists say that we've had seas and oceans. Okay. We should see about 250 times more sediment than we see in the sea. Another problematic assumption, layers of rock found in the Grand Canyon are bent without breaks. No breaks in it as they bend upward. Okay, you can see the layers that are different, but the bends itself, there's no cracking in them. And the only way rock layers like this could be laid down and bent is if they were laid down quickly and bent while still soft. Well, Christians have a great time to point to say, I bet this could have happened. Now notice we don't say for a fact, definitely, right? But we bet that this probably could have happened when? During the flood, right? Another problematic assumption is that dinosaur fossils have been found to contain soft tissue. Scientists from Montana State University found dinosaur bones that were not totally fossilized. Moreover, sections of these bones contained blood cells and hemoglobin. The fossilization rate means that these bones could not possibly be 65 million years old. When scientists were confronted with this, do you know what happened? Do you know what they said? First, they said, you have a mistake in the labeling of the bone. You must have found a human bone or an animal bone and not a dinosaur, a modern animal. And that was when that was proven not true. Then they said that it was planted. And finally, their official stance on this is it just means we don't know everything there is to know about the fossilization process as we thought. So even with even with problematic assumptions, even when, it's kind of right there, there's still another explanation. And next one, the Earth's magnetic field is rapidly wearing down. The magnetic field is what protects living things from solar radiation, and its current rate of deterioration, at its current rate, this field could not be more than 20,000 years old. The half-life of the field's energy, sorry, I missed the apostrophe there, is about 1,465 years. The deterioration is caused by freely decaying electric current in the Earth's outer core. Now that's important because the cause of the deterioration is a natural process. It's not a man-made process. Moreover, based on what we know about the conductive properties of liquid iron, this decay would have begun when the Earth's outer core was formed. So if the Earth's core were more than 20,000 years old, the starting energy would have made the Earth too hot to be covered by water. So all sorts of problems surrounding the magnetic field. Helium is another interesting one. So whether you are a scientist or teach science or not, most of us know the periodic table, at least not maybe by heart, all of them, but most of us know what it is, right? And what's the first element on the periodic table? Number one is, it has an H, if that helps, hydrogen, right? And it is the lightest element on there. And number two, coming close behind number one with a capital H, small e, is helium. So helium is, and we know this from the balloons that we blow up, right, at the stores, and then sometimes suck and talk in funny voices and so forth, right? Helium is a very light gas, right? If you're at a birthday party with a helium balloon and somehow, it lets go, or even if you're in a room or a gymnasium, let's say, okay, so there's no wind factor, where does the balloon go? Up, 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 right? Okay, so helium is the second lightest gas. It's also a noble gas, and so it does not combine well with other atoms. Instead, it diffuses and escapes. Well, obviously, if it's in the balloon, it's still trapped momentarily, right? But if it's just let out, it diffuses and escapes into the atmosphere. Helium diffuses so rapidly that all helium should have leaked out of all these rocks in less than 100,000 years. However, when drilling deep Precambrian granitic rocks, the label of the age supposedly of these rocks, right? In New Mexico, geologists recovered crystals that contain not only uranium, but large amounts of helium that had not leaked out yet. These rocks, though labeled with 1.5 billion year tag through uranium dating, had levels of helium which actually date them to be closer to somewhere between 4,000 and 8,000 years old. There is also not nearly enough helium in the atmosphere to support an old Earth. The leakage rate of helium gas into the atmosphere can be accurately measured. And even if we assume there was no helium at all in the original atmosphere and use the current rate of diffusion to kind of give us a max age, if you will, all helium currently in the atmosphere would have accumulated in 1.8 million years. Now, before you say, Erika, 1.8 million years is still way too many years, which I agree, big numbers sometimes can deceive us. 1.8 million years is 0.04%. That is 4/100ths of 1% of 4.5 billion years. So when we put that in perspective, I mean, I guess maybe think about this. Imagine if on a test, your students got 99.96% of the problems wrong. Okay. I don't think they got close to mastering that material, right? We wouldn't say, well, that's close enough, right? 1.8 million years is close enough to 4.5 billion, right? And that is kind of like at a very, very max ceiling, the absolute oldest it could possibly be. However, a catastrophic event, such as, say, a worldwide flood, would have released large quantities out of these rocks, right, of helium all at once into the atmosphere and would help support the age of somewhere between 6,000 and 10,000 years. Okay, but even when these numbers come up and they're like way bigger than what we say is right, we have to understand what the difference is between that, right? Could we get the secularists to say, okay, well, good, it's just 1.8 million years then? They would never say that. That's not nearly enough time because, again, it's only 0.04% of the time that they need currently to kind of try to explain how all this happened. All right, finally, although there are many other examples, there is very little salt in the sea to support old Earth. If the world's oceans have existed for 3 billion years, as evolutionists say, not only should there be more settlement on the floor, but they should be filled with about 70 times more salt than they have. Salt accumulates from rivers, glaciers, underground seepage, and atmospheric and volcanic dust. Today, 458 million tons of salt a year enters into our oceans. Only 27% is removed by natural processes. So using that rate of today and assuming absolutely no salt in the oceans at the beginning, which of course we don't assume anyway, but even if we assume that, our ocean's current saltiness would be reached in only 42 million years. Now again, 42 million years, way too much, but let's look at what that number is. 42 million years is only 1.4% of 3 billion. So some final thoughts for you. Some Lutherans steer away from organizations like AIG because of our theological differences. And we do have theological differences. They are more of the evangelical camp. We are Lutherans. Others are misinformed and think that because AIG is an apologetics ministry, which it absolutely is, and they say it right out front, that those who work there are theologically trained but are not, quote unquote, real scientists. In fact, we do have a Lutheran scientist, Dr. Menton, who works at AIG, and scientists who work at AIG, ICR, and other places hold PhDs in geology, cell biology, astronomy, physics, neuroscience, molecular genetics, astrophysics, meteorology, atmospheric science, and nuclear chemistry. So these are just not true. These organizations do provide us with great resources, evidence, and scholarly research for your classroom or homeschool. I wanted to speak just for a couple minutes. Pastor Taylor, who's one of the pastors here at Faith, where I attended my session yesterday, and we talked a little bit about the mature Earth theory. This floats around in Lutheran circles a little bit. Dr. Paul Edman, he's a Lutheran astronomy professor at Harvard. He's one who kind of accepts this. It's called the Omphalos hypothesis. It's the idea that God created a mature Earth and that it looks old because God created it that way. Now, on the surface, that sounds like a very easy way to explain it, but we need to be very careful with this idea. So I want us to do an exercise for a minute. Close your eyes and imagine yourselves in the Garden of Eden. Picture the lush vegetation. See Adam and Eve standing behind a bush, okay, because this is before the fall. Okay, the animals are doing what they do in a very gentle manner. All right, now open your eyes, okay? You pictured Adam and Eve, right? How old were they? How old did you picture them? 21. 21. What? 30. 30. Okay, somebody yesterday said 100. We could even say 100 because they lived for a long, long time, okay? Maybe they were already 100 in terms of their body. How about the tree? How about the vegetation? How many rings did it have, right? How about the really tall ones, right? 100, 200, right? Yes, they were years, right? They were made older because how old were they? 2 days, a week, okay? But not thousands or millions of years, right? So how many years does that add? It does add some years to it, but it's inconsequential. Right? 100 years. We already have this range of 6,000 to 12,000. 100 years, give or take, that doesn't change anything. Stars, as we talked about before, they are not living. They don't have births and life cycles. They were created in whatever filled capacity of fuel that they have to give off the light so that we know how hot the star is and how much fuel it has in there. But that's it. God did not put fossils in the ground for us to find later. Those all came after the fall. So yes, the earth, and mature is probably not the right way to describe it because it just makes it sound, again, old. We do know that God created things in the way they needed to be created in order for life to exist on earth. And in some cases, that meant a half-fold candle of our sun so that it could be the right temperature and so forth. And yes, the trees already had fruit on them. God didn't just, when he create them all as seeds, and we had to wait for them to grow. And yes, when God put stars in the sky, he not only put them at the distances that he put them, but he put the light immediately reaching us. Not started the light and waited for millions of years for the lights to get here. Okay. So he did create a formed earth and universe that was needed and necessary and good. But he did not create things that were simply looking old so that later on we could be really confused with this whole evolutionary theory. Most things in the universe look old because of the assumptions, not because they are old. Applying different assumptions makes those same objects look young. And I went 1 minute over, I apologize, but thank you for being here.